All right, guys, beautiful. How are you? Good to see you. Well, I can't really see you, which is kind of sad. So, anyway, let's do this, okay? The last three examples that we have here in our notes are start off with a sphere. So, a sphere has very nice formulas. So, we don't have to worry too much about those, okay? So, the idea to start off is that surface area is what you could touch. Imagine this is a ball and I'm trying to touch everything around it. You can't touch the inside. So the base here, you don't really have a base, okay? Because you can't touch the inside. You're just touching a spherical ball. So area of base I don't need to worry about. Lateral area is the whole outside. The lateral area is just the outside part that doesn't include the bases. So the lateral area is actually a very nice formula here. And you'd think it'd be really confusing, but it's just 4 pi r squared. This is the outside of the ball. Okay, that's it. I mean, that's the lateral area. It's very nice. So that's 4 pi r squared. Where's my calculadora, the Explorer? 12 times 12 times 4. This is 576 pi. Okay. Luckily, that's the outside area, which is the same thing as this. It's just 576 pi. Easy. Because there is no base. It's a ball. It's an open ball you're touching. Easy. Okay? Last but not least is volume. This is its own formula. This is its own formula. This is a little weird one. Okay? The volume formula is 4/3 pi r cubed. This is the thing that you got to be careful with. 4/3 pi r cubed. This is just its own formula, okay? As long as you know the radius, you can find all this. So this is 4/3 pi of 12 cubed, which we could calculate that, times 4/3, okay? 2304 pi, and this would be units cubed. All right, so a little weird, but just know that you have those formulas there. So you just, if you know those formulas, write them down. You could use them whenever. Even on something like an SAT, they actually give you the formula for the volume, so you don't have to remember that. As long as you just write it down, you could use that to find the volume. But the surface area is super chill formula for that too. Okay? Gorgeous. Let's go to the back. All right. This is a little different. Okay, this we got Hemi Lovato. Okay, I hate my jokes. Okay, with a hemisphere, this is a little different. This does have a base because the base of this thing is now that. It's a circle, so there is one base here in a hemisphere. So the one base now that you could lay down flat on. It's just pi r squared. That's pi of 4 squared, which is 16 pi. So this does have a base. That's the big idea here, is that this is the blue. Okay, so that's the base, which is different than what a sphere had. A sphere does not have a base. The lateral area is this curvy part. So this is the yellow. Okay. So the lateral area is that curvy part on the outside. Well, this lateral curvy part here is half of the curvy part on here, right? Because if I just got rid of half of the sphere, there's still that curvy part. And if that whole thing was 4 pi r squared, the lateral area for a hemisphere is 2 pi r squared. Because it's half the lateral area of a sphere. So it's 2 pi r squared. That's 2 pi times 16, which is 32 pi. Okay, and that's the outside part. So very similar from a hemisphere to a sphere, except a hemisphere has this base. The other one doesn't. So total area is the one base plus the lateral area, which is 48 pi. Okay, so nice and easy. Okay, and then the volume formula, okay, this is a little weird. The volume formula is half of the volume formula over here. Okay, because this is a whole thing, whole volume of a whole sphere. I want half of that. So the volume for a hemisphere is 2/3 pi r cubed. Okay, this is just half of sphere. So again, you don't need to remember that formula. You have that right there for you. Okay, it's just half of that. So it's 2/3 pi of r cubed. And where's calculadora? 4 times 4. Let's do nice math frac. 128 over 3 pi units cubed. All right, love it. So there you go. There's your volume for a hemisphere. Okay, but just think logically. Think logically. Watch the video. It should hopefully help. Okay. Last but not least, for the notes, we have the fun guy. Okay, we have this pencil. Okay, so what we're going to do is we're going to find the area of the pencil. So here's the fun thing about this, is that a base is like something flat you could lay something down on. Like this cup right here has the base at the bottom. It lays flat. There's the cup. But in this shape, there's no flat thing you could lay it on. So there is no area of base. There's no area of base. But there's totally a lateral area. So the lateral area, I'm actually going to split it into 3 different parts. 1, 2, 3. Okay, so this is where you got to be very careful. The lateral area is like the outside part. So that's like the top of this thing. That's the rounded center part, and there's the pointy bottom part. So I'm going to do it in 3 different colors. This is the yellow. This is going to be blue. And the next one's going to be pink. Okay, so just so you know, this is like a total test question. Like, totes, my goats, you're going to see this puppy. So, let's do that. Alright, so we're going to start with the yellow. So the yellow part is for hemi-levato. It is for the hemisphere. Okay, the lateral area of this thing, okay, remember just the outside part is, that's all it is. It's the lateral area that we talked about earlier in a hemisphere, 2 pi r squared. All right, so if you know that formula, you found the lateral area of the hemisphere. Well, the r is 7, since this is 14. So this is 2 pi of 7 squared, which is 2 pi times 49, which is 98 pi. Okay, that's the hemisphere. Okay, using my formulas. Okay. For the cylinder, which I'll put in blue. Okay, the cylinder, I am only finding the lateral area of the cylinder. I can't find the top and bottom of that cylinder because it's inside the shape. So I just want the curvy rounded part. Well, that curvy rounded part goes back to what we did earlier, okay? Where this is the height and this is the circumference. Okay, this is from our notes earlier. That's just what that blue part is. So in this case, let's see what we have here. Oh, woof, we're kind of missing some stuff. It's okay. If we want this height, okay, oh, this sucks. We don't know it yet. We actually don't know it. We know this is 7. We know this is 7, right? It's the same thing. But we don't know this yet. But what we do know is that if you look at this radius is 7, from the center straight up top is also 7. So I know that from here to here is 7. Okay, the whole thing is 40. But I still have a little bit more. We still need to know what this is here, because we have to subtract that from 40 to get what's left. Well, luckily, you have the radius is 7. This is 25. If you make a right triangle or use triples, this is a 7, 24, 25 triangle. So this piece here is 24. Okay, from top to bottom. But again, I'm using just kind of like a right triangle in here. Okay, From there, if this is 7 and this is 24, that makes 31, which means that this is 9. Okay, so the height of your cylinder is 9. And the circumference is 2 pi r. So 2 pi times r would be 14 pi. Okay, and then 9 times 14 pi is 126 pi. So that's the lateral area of the cylinder. Beautiful. So that took a little bit more work because they didn't give us all the information, but we have that. Okay. Finally, of my girl Connie. All right. The cone. The cone, we know that the lateral area of a cone is a nice little formula, pi RL. So this is from the notes, pi RL. We have L is 25 because that's the slant height. Okay, so this is pi times R times L. And I should get 175 pi. Okay, and that's the area of the lateral area of the cone. Okay, so in bigger terms, the total area is all these three things added up. So if I add up all that, 98 plus 126 plus 175, that'd be 399 pi. Okay, that's the total area of adding those three things up. Okay, so this one you had to think a little bit harder. I know this is definitely the Wolf McGee. This is way easier. Okay, because when you're doing lateral area, it's like you're picking and choosing. Oh my God, help me! From part of the total area. But with volume, it's just the normal volume. There's no pieces missing a volume. It's just volume of a hemisphere, volume of a cylinder, volume of a cone. So I'm going to split up the same way I did before. Hemi, cylinder, and cone. All right, and we're going to find the same information, but now volume, again, way easier to find. I don't know where blue went. I think blue ran away. No, it's right here. Okay. So last but not least, ooh, I'm so exhausted. I've made like 12 videos in a row. I'm going to throw up. Okay. Volume of a hemisphere, which we can go back and look here. The volume of a hemisphere is 2/3 pi r cubed. Just straight up fact. So this is 2/3 pi r cubed. That's just a straight up fact. So that would be, if we calculate it out, oh woof, 686 over 3 pi. It's a fraction. Okay, that sucks. Okay. The volume of a cylinder was area of base times height. The area of a base of a cylinder, that's pi r squared. The height of the cylinder was 9. So 49 times 9. That's 441 pi. Dope. There's that. And the cone, the volume of a cone was 1/3 area of base times height. Okay, so there's 1/3. The area of the base is still pi r squared. The height of the cone, be careful, height of the cone was 24. So if I calculate all that, 392 pi. Oh my gosh, I'm gonna throw up. Okay, so if I add these all together, I'm not gonna add them perfectly, but these will definitely go together. I'm just gonna leave it as a fraction plus the total. So it's 686 over 3 pi plus 833 pi. If you want to add it into one fraction, that's probably the best, but that's totally cool with me. Hopefully you don't get nasty answers like that. But again, that's the end of our packet of notes that we've been doing the last couple of days. Hopefully that made sense. Okay, let me know if you have questions.